Our final lesson in 6.1 has us going back to graphing. In this lesson, we'll look at changes in your input value and how it affects the shape of your graph. If we look at the equation on the left, y equals a times b to the x minus h plus k. This can describe any translated exponential function. In day one, we looked at how your a value and then that k value affected the shape of the graph. Now we're going to focus with changes with our exponent, that x minus h. Anything with x can move your graph left or right. And if you recall from all kinds of transformations, it'll go left or right in the opposite direction. Let's try a couple of examples. It says graph each function. Describe the graph in terms of transformations of the parent function f of x equals 2 to the x. So that's going to kind of be our basis, and we'll describe these transformations from that. How do the asymptote and y-intercept of each function compare to the asymptote and y-intercept of the parent function? Well, the parent function is going to model what we did in day one. We know that the y-intercept was 0, 1, and the asymptote is the x-axis, or y equals 0. Let's see how g of x and h of x compare. We'll start with g of x. G of x equals 2 to the x minus 3 exponent plus 1. Let's see if we can describe the transformations. Notice there's nothing in front of x, in front of the base, so our a value is 1. But then we have our x minus 3. X minus 3 means the graph is going to shift or move 3 units to the right. So we'll say moves right 3. And then the plus 1 means everything is going to move up 1. To verify that, we'll simply make a table and plug values in. Now we're going to plug in as many points as we find valid on this graph. All right, let's start with 0. If we plug in 0 for x, 0 minus 3 is negative 3. 2 to the negative 3 power would be 1 over 2 to the positive 3 power, which would be 1/8. 1/8 plus 1 would be 1/8, or 1.125. Let's pick another one, positive 1. If we plug in 1 for x, 1 minus 3 is negative 2. 2 to the negative 2 power would be 1 over 2 to the positive 2, or 1/4. And 1/4 plus 1 would be 1 1/4, or 1.25. Now I'm thinking about our power chart, or you could always plug these into your calculator. Either way would work. If I plug in positive 2, 2 minus 3 as my exponent becomes negative 1. 2 to the negative 1 is 1/2, plus 1, which would be 1.5, or 1.5. If we plug in 3, remember we said it moved 3 to the right? Watch what happens. 3 minus 3 is 0, and 2 to the 0 power is 1. And that would be what your original y-intercept would have been on the parent function. However, in this case, we translate that point over to 3, 2. Well, 2, not 3, 3. All right, 3, 2. And again, we'll keep going. We'll plug in 4. 4 minus 3 as my exponent is 1. 2 to the first power is 2, plus 1 is 3. We'll plug in 5. 5 minus 3 is 2. 2 squared is 4, plus 1 is 5. Plug in 6. 6 minus 3 is 3. 2 to the third power is positive 8, plus 1 is 9. And if we plug in 7, we get off of our graph. Go ahead and pause the video and plot these 7 coordinates, and then we'll see if it matches our description. When I plot my points, I see the curve that looks similar to what it looked like on 6.1 day 1. Notice we're not going any lower than positive 1, so it looks like that's going to be our horizontal asymptote. So I'll draw that in. See how it starts to level off and not cross over that? And that's going to be compared to that plus 1 in the equation. Go ahead and draw a curve from left to right that flattens out on the left and goes up through the points on the right. Hopefully your curve looks something like this. Now let's take a look at our y-intercept and our asymptote. Our new y-intercept didn't necessarily move up 1, did it? And it's because of the translation to the right. So everything kind of adjusts what happens to our kind of key values. So our y-intercept moved up a little bit, and our asymptote also moved up, didn't it? It moved up to y equals 1. All right, let's try that second example. H of x equals negative 2 to the x plus 1 power minus 3. Taking a look at this, what I want to do is make sure that negative isn't associated with my b value. Right next to it, I'm going to simply rewrite this as h of x, whoops, there we go. Oh, I won't go in there. There we go, equals negative 1 times 2 to the x plus 1 power, and then minus 3. That negative 1 is actually our a value. And what that's going to do is reflect this curve over the x-axis. That's what a negative a value does. It's going to reflect over the x-axis. And now let's look at our exponent, x plus 1. That's actually going to move everything to the left 1. And then the minus 3 is going to translate or move everything down 3. Now let's see if we can get that to happen with our table. Again, we're going to plug in as many points as we can to help accurately sketch the shape of this graph. And if you're drawing this on your notebook paper, just try the best you can. I'm going to start with 0, and then we'll go from there. If we plug in 0, we're going to take our time, and we're going to plug it in over here in this blue equation. 0 plus 1 is 1. That's not so bad. 2 to the first power is 2, but then we have to multiply that by negative 1. 2 times negative 1 is negative 2. Minus 3 drops this all the way down to negative 5. If I go 1 to the right, plug that in for x, 1 plus 1 is 2, 2 squared is 4. But negative 1 times 4 would be negative 4, minus 3, negative 7. Plug in 2, 2 plus 1 is 3, 2 cubed is 8, times negative 1 is negative 8, minus 3 already puts us down to negative 11. This means we're going to have to go to the other side and plug in negative values for x to see what we can get on our coordinate system. If I go on the other side of 0, if I go to negative 1, negative 1 plus 1 is 0, and 2 to the 0 power is 1. Times negative 1 is negative 1, minus 3 puts us at negative 4. If we plug in negative 2, we're just going to keep going. Negative 2 plus 1 is negative 1. 2 to the negative 1 is 1/2. Negative 1 times 1/2 is negative 1/2. Minus 3 would be negative 3.5 or negative 3.5. Negative 3. Negative 3 plus 1 is negative 2. 2 to the negative 2 is 1 over 2 squared, or 1/4, times negative 1 would be negative 1/4. Minus 3 would be negative 3.25, or negative 3.25. Keep going. Negative 4. If we plug in negative 4 plus 1, we get negative 3. 2 to the negative 3 would be 1 over 2 to the positive 3, or 1/8. Times negative 1 would be negative 1/8. Minus 3, negative 3 and 1/8, or negative 3.125. Can you guys kind of tell that it's tapering off a little bit? The numbers aren't getting bigger faster. Let's try one more. This will kind of solidify it for us, I think. If we plug in negative 5 plus 1 is negative 4. 2 to the negative 4th power would be 1 over 2 to the positive 4th, which is 1/16. Times negative 1 would be negative 1/16. Minus 3 would be negative 3 and 1/16, or negative 3.0625. Go ahead and plot these points, and we'll see what's happening with our graph. If you look at the points plotted, I can see that it's definitely not a linear function. This is going to be exponential. And as it kind of increases, or as it actually looks from the left to the right, I can see it's getting really, really close to -3, but it's actually not going to cross over that. So -3 is going to be our asymptote. And if we look at h of x, that -3 is what validates our answer. So go ahead and draw in your asymptote carefully. And that's our boundary for our function. Draw a curve through those dots, making sure that you don't cross over the asymptote on the left, but that your value drops significantly over on the right. And hopefully when you're finished, your graph looks something like this. Notice our y-intercept changed significantly. Our y-intercept moved down to -5. And our asymptote changed from our parent function as well. It dropped down to y equals -3. That should be an equal sign right there. We'll try that again. Y equals -3. I'm hopeful that this graphing section, along with day 1, will be helpful for you on your worksheet today.